Hi everyone, I'm Fraser Cain. I'm the publisher of Universe Today, and I've been a space and astronomy journalist for like over 20 years, 23 years at the time of this recording. And this is my live question and answer show where you can ask your questions either just anywhere across my YouTube chat or other places, but also you can come and show up live and I will answer your questions in real time. And then you and others can ask follow-up questions. We do these shows every Monday at 5 p.m. Pacific time. And just a reminder that we're going to put little codes up as we go through each one of the questions. And that's your chance to let us know what you thought was the best question, best answer. And so down in the comments, as you are asking questions of your own or just replying or discussing some of the ideas that were talked about, go ahead and put that little code. We'll count up the codes, and whoever gets the most votes, we will give them a shout out in an upcoming video. All right, let's get into the questions. Brian, are any elements being formed in quasars? If so, would we be able to see their emission lines? Yeah, in theory, there are a ton of elements being manufactured in quasars. So what's a quasar? Quasar is a supermassive black hole which can have millions, potentially billions of times the mass of the sun. And when there's a lot of material falling into that black hole, it becomes actively feeding, then astronomers call that a quasar. And for the longest time, they didn't know what they were. They were just these incredibly bright objects that they knew were really far away. And now we know that what they are is you've got this massive amount of material, stars, planets and stuff going into this supermassive black hole, but it's piling up into this accretion disk surrounding the black hole. This disk heats up, you get these intense magnetic fields that swirl around in this accretion disk, and it fires out jets of material above and below the supermassive black hole. Now, this isn't stuff that's being released from the black hole, it's the stuff that's being released shortly before it goes into the black hole. And the analogy that I always like to use is like when you pull the drain on your bathtub and your whole bathtub doesn't just immediately go down the drain, you get this swirling. All of this water is piling up, waiting for room in the pipe for the water to fully drain. And so the quasar is just when it's eating, and then it's just a regular old supermassive black hole when it's not eating. And these quasars, and especially this accretion disk that's around these quasars, is detectable because it's giving off an enormous amount of X-ray radiation. The Chandra X-ray Observatory and other X-ray observatories can detect these emissions coming out of these accretion disks around these black holes. And what's happening is that this material is piling up around the black hole. It's getting so hot, so dense, that it's essentially turning into a star, like a big donut star around the black hole. And you do get new atoms forming. You've got the hydrogen turning into helium. I'm not sure how far up the elements that it goes. Definitely not all the way to get to iron, and you don't get supernovas going off inside the accretion disk, but you do get heavier elements being formed. And then because you've got these magnetic field lines that are spewing some of this material out into space before it can go down into the black hole, you can have this stuff flying out and seeding nearby areas. And this is thought of one of the possibilities for how you can have nebulae getting seeded with heavier elements, the kinds of stuff that we have here on the Earth. Now, also supernova, also colliding neutron stars, also massive stars blowing off material and dust, but maybe from supermassive black hole accretion disks also throwing material out into space. Ed, when NASA SpaceX lands on the moon in the not too distant future, what will the audio video coverage be like? Will it be high def, 4K? How much of a delay will live coverage have? When you think back to the Apollo era, like 50 years ago, and you had these grainy black and white, in some cases video footage of the surface of the moon that was being broadcast and picked up here on Earth. But the technology was absolutely brand new, very low bandwidth, very low resolution, black and white. It essentially lets you know that yes, indeed, humans were setting foot on the moon, but it wasn't great. Now, the quality of the cameras that we have, the size, I mean, we all have HD cameras in our pockets at this point. And so flying a large number of high definition cameras up to the moon is not going to be a problem. The challenge is going to be the bandwidth, sending this stuff back home to Earth from the moon. And you can get sort of a version of this when you go and look at the International Space Station website that's curated by NASA. They're releasing tons of videos, photographs taken by the astronauts, videos that they're taking, them playing around in space with water and things like that. And you're going to get something that's very similar to that when they go to the surface of the moon, but the moon is so much farther away than low Earth orbit. And so the bandwidth is a lot more constrained, and they're going to have a lot of information, telemetry information, mission data they're going to be wanting to send back and forth. And there's going to be a limit to how much they can send. But we will definitely get some high resolution images, some high resolution video that we're all going to get a chance to enjoy. It's just not going to be like nonstop live television stations in the way that you might be hoping. But the other thing that I hope we're really going to be able to see is this revolution in cameras put on the spacecraft themselves. When you think about, say, the Falcon 9 launches that SpaceX does, you can see every part of the whole rocket system work, the rockets land, etc. And I think we're going to see something very similar. We're going to see the rocket take off. We're going to see a view from the rocket. We're going to see the stages separate. And this is useful just to NASA for being able to figure out if anything goes wrong or just to make sure that everything is working perfectly. But at the same time, also to give us a really much better view. And if anyone at NASA is listening to me here, do a great job of this. Like, planet Earth, we're all waiting for when there's a return to the moon, for it to be really, really well documented, for there to be a lot of cameras that we can see things from all the different angles, and don't worry about like how it'll be edited and covered and all that kind of stuff, because we'll all do that. But just make sure those raw feeds are there so that we can all get a view of what's going on the moon. David Swift. Comet C 2014 UN 271 has just been announced as the largest comet ever spotted and is heading this way, as described in various sensationalist reports. The nucleus is said to be about 75 miles wide, but how close is it likely to get to us? Not least because it should put on a good show, perhaps. Maybe? Thanks. Yeah, I'm sure we've all seen the story making the rounds that the biggest comet ever seen is headed towards the Earth. This is true. It is the biggest comet that we've ever seen. And it's really big. Like, it's close to 100 kilometers across. Far larger. It's like a factor of 10 times bigger than most of the kinds of comets that we see. And it is coming towards Earth, towards the inner solar system. But the closest point of its orbit is going to be the orbit of Saturn. And so it's going to get to about the orbit of Saturn, and then it's going to fly back out into space. And you're not going to be able to see it with the unaided eye. You're not going to be able to see it with binoculars. You're going to need a fairly big telescope. And really, it's going to be the Hubble Space Telescope. It's going to be some of the big observatories here on Earth that are going to be viewing it when it reaches its closest point. And so right now, the clickbait style journalists are jumping on this and hoping people don't read the small print where it's not going to get very close. You're not going to be able to see it. You're going to see some pictures released from Hubble. In fact, there have been some pictures released from Hubble already, and they're going to get better as it gets closer, but not a lot better and not a lot closer. I mean, we covered on Universe Today about how big and impressive a comet it is, but not like it's coming right at us. So this is just what it takes to get clicks in this modern age. Wilhelmo de Occidento. Why would a society send out von Neumann probes everywhere? What would be the purpose? To understand what's in the Milky Way. That's it. If I could hand you a book, and in that book was a list of the coolest star systems in the entire Milky Way, and the coolest planets, and pictures of the surfaces of those planets, and maybe even from down on the surface, and what you could see if you could stand on that planet, wouldn't you like to know? Would you not want to open up that book and take a look? And what if the price of being able to do that is to send out one spacecraft off to Alpha Centauri, and when it arrives at Alpha Centauri, it makes copies of itself, and those copies go to other places, and as they arrive at different star systems, they send information back to us, and we compile it into this book, and I give it to you, and you get to look through it. Just knowledge is reason enough to send out self-replicating robot probes across the Milky Way. And whether, you're trying to scout out your enemies, understand any threats that could be out there, or just purely to know better about the Milky Way, the galaxy that we find ourselves in, it's a perfectly reasonable reason to send out the von Neumann probes. So I think we should do it. I think we will do it eventually. And I want to know the answers to all those questions. What's out there? Me, but in space. I'm from Germany, Fraser. Could you expand on von Neumann probes? Everyone keeps saying that they are just 100 years or so away, but we haven't even built a 3D printer that can print itself here yet. Sure, but technology advances very quickly. We are at the point, like 3D printing has really been going for the last, say, 10 years. And we've gone from printers being able to lay down just this one kind of plastic into very low resolution figurines and statuettes and things like that, to very sophisticated 3D printers that can print very complicated objects with often different materials at the same time. There are 3D printers that can print things out of like titanium and other metals, ceramics, plastics, glass. So almost any kind of material that you can think of. 3D printers have been tested in space, and the field is still growing. It's still just in the field of hobbyists, but you can imagine we're going to get closer and closer where you'll have a 3D printer in your home where you'll be able to get a certain amount of things that you require 3D printed. And it doesn't seem like a bunch of leaps that will eventually end up with the technology that you can do manufacturing in space using 3D printers. Maybe it's not 100 years, maybe it's 200 years. Or maybe it's 500 years. That's still a blink of an eye compared to how long humanity's been around, how long the Earth has been around, how long the universe has been around. And once you get to that point that a robot can make a copy of itself, and then those copies can be sent to other star systems, then you're off to the races, and you only need to send one. And then they can just keep going and going and going. Is it Bill Gates said this, that we often overestimate what is going to be possible in a year, but we underestimate what will be possible in 10 years. Just wait until you see what the field of artificial intelligence, content creation, like GPT-3, but in 10 years from now is going to be like, or what 3D printing is going to be like 10 years from now, or even rocketry. Like a lot of these technologies now, once they get onto this exponential growth curve, it's pretty astonishing how well and how quickly they can change and become more sophisticated. So stay tuned. It doesn't seem unreasonable to me that 100 years, 200 years, 500 years, this technology will be ubiquitous and capable of producing very complicated objects. Douglas Wilkinson: when two black holes collide, the resulting black hole is always several solar masses less massive. How is this possible? Yeah, when you see reports of two black holes colliding, you get the two black holes, their masses, you get a mass of the black hole that remains, and it feels like the numbers aren't adding up. And the other thing that you see is that a large amount of energy is released from this collision that takes away from the mass. And what's really happening is that essentially the black holes, as they are spiraling into each other, have a tremendous, like a mind-bending amount of kinetic energy. And when they collide, that kinetic energy is converted into gravitational waves. And so the gravitational waves aren't actually coming from the black holes themselves. It's coming from the kinetic energy of their collision. And so you'll see things saying like 5 solar masses of energy, or 5 times the mass of the sun of energy was released, things like that. And that's coming from the kinetic energy of the colliding black holes, not from the black holes themselves. They're not actually giving up their mass to create this new larger mass black hole. It's the energy of their collision that's causing it. Cyberpunk: shouldn't the rest of the world under the UN umbrella have some kind of say, like a voting of some sort, when it comes to NASA broadcasting a radio signal of our location? This is probably based on a fairly recent news story where researchers designed a new signal that could be sent out to alien civilizations to give them information about humanity. And there was a version of the signal that was developed back in the 80s. I think Carl Sagan helped design it, and it was sent out into space from the Arecibo telescope and gave information about Earth, the solar system, the planets, humanity, things like that. And so they thought, well, like, what would be a better version of that signal to be able to send out? But right now, nobody has actually sent out that signal into space. Is it unwise to send a signal to space to let the aliens know that we're here so they can come and steal our water, harvest us for food? The aliens know we're here. Like, if there are aliens out there, they know we're here. Just in the same way that we're building things like the James Webb Space Telescope, we're going to be building enormous versions of James Webb in the future. Eventually, we will be building telescopes, interferometers, where one 100-meter telescope is on one side of the sun and another 100-meter telescope is on the other side of the sun, and they're working together as an interferometer. Or we've got a telescope out to the point that it can use the sun as a gravitational lens to be able to view planets with incredible accuracy. Earth itself is beaming a constant signal into space that there is life on Earth. All of the plants, the cyanobacteria, they've been doing this for 500 million years. Anyone with a telescope who was able to look at the Earth could see there's something really weird going on about that planet. And more recently, as the rise of humanity, rise of our air pollution, things like that, our radio traffic control, the jig's up. We've been beaming this information out into the universe for 500 million years to some extent. I can't imagine that an alien civilization capable of crossing the gulf between stars to travel light years away hasn't built a really big telescope and has scanned every single star system within reachable range for a very long time. So it just seems impossible to me that if there are alien civilizations out there, that they don't know that we're here. And so, like, you could say, like, well, it could be a risk, right? Like, why would we do it? We could be risking the fact that the aliens are going to go, what's this? And then they'll come and destroy our planet. But the thing that we also risk is not making contact with other civilizations. Think about the benefits. If we could become pen pals, space pen pals with an alien civilization at Alpha Centauri and be sending useful scientific data back and forth to them, how could that help our civilization move forward, have a second opinion about the universe? It would be enormous. So you kind of have to weigh those pros and cons. On the one hand, stay quiet, even though every part of this planet, our technology, is broadcasting our existence to anyone who can build a high quality telescope. And then on the other side, what are the benefits or what are the downsides of remaining silent and not making contact with the rest of the Milky Way, of the Galactic Federation? So I think it's kind of a moot point. It doesn't really matter. The aliens know we're here. We're about to know where they are. So it's harmless, I think. More questions in a second, but first I'd like to thank our patrons: Pranakasha, Peter Cosgriff, Alan Gross, Alex Getty, Adam Annis Brown, and the rest of our 856 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. Bob Hopeldorf: what do you think about the practicality of bowl spin habitats on low gravity worlds like the moon? We've talked a lot about this idea of the difficulties of trying to live on other worlds like the moon and Mars. And so if you go to, say, Mars, yeah, you can live underground, and then that protects you from the terrible cold temperatures, the lack of atmosphere, the radiation that's coming down on you at all times. But the one thing that you can't get away from is the fact that they have the low gravity. 30% the gravity of Earth on Mars, 15% the gravity of Earth on the moon. And we don't know what effect that's going to have on the human body. Will humans be able to gestate pregnancy? Will there be birth defects? We just don't know the answer to that question. And for now, if Musk and crew are planning on sending hundreds of thousands of people to Mars, we're just going to run that experiment in real time. So one of the possibilities you can do to try and deal with that is, you're calling a bowl spin habitat. I haven't heard that term before. I've heard a gravity train, but the gist being that you have a Ferris wheel that's on its side that has angled walls. You spin it around and you get to take the centripetal force that's pushing you out matched with the gravity that's pulling you down. You balance it out and you can essentially simulate Earth gravity on a place like the moon and Mars. And I guess, sure. But imagine, you've gone to Mars. You've gone to a place with a solid surface that's got dirt, it's got all these great resources, but you then have to build a gigantic, hundreds of meters across wheel that is spinning nonstop on the surface of Mars to stop your bones from from weakening, to stop the fluids from redistributing in your body, and to potentially to prevent these birth defects. It's a mega engineering project. We would have a tricky time building something like that here on Earth, not to mention building it on the moon or Mars. And so what if we can't do it? What if we can't live on the moon and Mars without building these giant things? And then if you are living in this gravity train all the time, you might as well be living in space where you don't need a power system. You just start the wheel spinning and then you just now have artificial gravity for forever. I really feel that the long-term viability of human beings living in these lower gravity worlds is going to be really tricky, and we're going to have a hard time going beyond the research stations on all of these places. As I always say, gravity wells are for suckers, and this is one of the reasons. So let's live in our giant orbital L4 colonies, free of the brutal gravity that's trying to pull us down, but not enough gravity. Let's make our own gravity, or live on Earth. Earth is pretty great. Peter DeYoung, the Webb telescope is almost ready to start observations. What can you expect as a first result? We have no idea. They're being really coy about what it is that we're going to see with Webb as the first target. I mean, what would you look at? Well, you wouldn't do a deep sky survey because you're going to want to do a very long exposure. You're probably going to want to take a picture of something that's very well known, that is really interesting in the infrared, that has been seen many times before. And so you can compare the capability of Webb versus the pictures that have been taken before from the ground or from space. So my guess is some kind of well-known nebula, a star-forming nebula, that you'll be able to see the knots of dust. Like maybe it'll be the Eagle Nebula or something like that. That would be my guess for what we're going to see as the first image released from Webb, to show how good it is, how much better it is than what came before. So you're going to be looking at a picture that was probably taken by Herschel, and that way they can compare and contrast how good Webb is compared to what Herschel did, or something compared to Spitzer. So that's my guess. All right, so place your bets. It'll be a picture taken by Spitzer compared to this new picture coming from Webb. So we all ooh and ah on how much better it is. That's my guess. Verse Stovsek. How do we know the Oort Cloud exists? Can we directly see it? The only way that we know that the Oort Cloud exists is because we see comets falling into the inner solar system. You can measure the orbits of these comets, these long period comets, and they're on an orbit that took hundreds of thousands of years for them to go from the outer reaches of the solar system down into the inner solar system. And from that, you can calculate that the Oort Cloud is this area that could be 50,000 astronomical units away from the sun. But they're all so far away. You can't observe something that's 50,000 astronomical units away from the sun unless it was a star. And so we can just infer the existence of the Oort Cloud by the objects that we see falling into the inner solar system. They have to come from somewhere. You can calculate their orbits, and they're all coming from this region. And so that's why it's been theorized that this cloud of comets exists out there. ATL 530. Assuming we get Starship up and running, and after your recent interviews, what telescopes are most critical to loft into space over the next decade? In the short term, if Starship works, in the short term, we will see a lot of these telescopes that were going to be planned to launch on various other spacecraft, be it SLS or ULA or Ariane, things like that, will be shifted over to Starship, especially if it is like as cheap and as reusable as they're hoping. It's really hard to turn away from a discount of $100 million, $200 million when you're launching your telescope. That roughly, in many cases, can give you double the telescope. And there's a lot of excitement from NASA to be able to do that. But nobody is designing for Starship yet. And Starship has a much bigger fairing and a much taller fairing. And so in theory, you could fit a telescope like James Webb, one with a mirror that's 6.5 meters. You could fit that inside Starship without it having to fold. And so the implications are fundamental, that you now have to kind of go back to the drawing board. and say, okay, you now get to make a telescope that is far bigger, but also can be a lot less complicated. It can be a lot simpler because you've just got this giant open space that you can put your telescope into. And right now, that's not the way that astronomers, that people who are designing missions have to think about it. Weight is such an issue. Size is such an issue. They focus a lot of their effort on shaving every gram they can off of their spacecraft. And suddenly when you've got a spacecraft that's capable of lofting hundreds of tons into low Earth orbit for a few $1 million, it completely changes the math. And so we don't know yet what are going to be the best missions to fit that kind of capability. And so I think what you're going to see in the short term is you're going to see every mission that hasn't found a home yet is going to be launched on Starship. It's going to be hilarious. You're going to have these tiny little missions that are sitting at the bottom of this cavernous launch fairing because it's still cheaper to launch on Starship than to launch on some other launch platform. But then over time, someone is going to design the perfect space telescope that fits inside that 9-meter launch fairing and yet is as heavy as it wants to be and is simple and kind of brute force can do astronomy. So we're still just at the nascent stages and nobody is really taking it seriously yet to the point that they're designing space telescopes for it. But I guarantee the second this thing flies, the second it returns safely from orbit, the second it's been flight proven, you're going to see missions designed for Starship happen right away. And it'll be a new era in astronomy. It's hard for us to even comprehend and imagine what it's going to be like after Starship flies. It's such a game changer. If it works. If it doesn't work, well, it's just another failed launch platform. John Morano. Could a heavy exoskeleton spacesuit simulate an Earth-like gravity on the moon? If you wore some kind of exoskeleton suit, a weighted suit that was pulling you down, that would help with some of the problems of living on the moon. Like when you're in microgravity, when you're floating around in space, you can't wear a weighted suit because you're experiencing no weight at all. And so it just won't help. But once you're on the moon and you're experiencing 15% gravity, then yeah, you could wear giant weights across your whole body to get to the point that it simulates what it feels like to be down on Earth. And that might actually help not just with strengthening your bones and improving your muscles, but things like just walking around. Like we're totally accustomed to walking on Earth, and you're going to have to learn new ways of walking, new ways of interacting with your environment, of picking up cups and drinking and things like that when you're on the moon. It's going to be very weird. And so it might very well be that it makes the most sense to put on your heavy suit when you're on the moon or when you're on Mars. And that way you can feel like you're in normal gravity for most of the time. But that's only for your external body, only for the things that, for your skeleton and for your muscles. It doesn't help with your internal fluids, things that the suit just isn't going to help. And so you're going to need some kind of artificial gravity, like that gravity train that we talked about earlier, to permanently deal with all of the issues, the eyesight issues, the fluid redistribution issues. There's seems to be issues with your heart, with your brain. So those are going to take actual proper gravity or simulated gravity through centripetal force. But until then, there's nothing we can do to really stop the downsides. Peter Gertis. Do you think that Musk, Bezos really believe that going to Mars is about protecting civilization? It seems obvious that underwater ground would be better for all that. Is it all PR? That's an interesting question. I think for Jeff Bezos, he's less interested in going to Mars. He's more interested in going to space itself. And the rationale that he uses is let's build orbital facilities to do heavy manufacturing, power generation, resource acquisition, things like that, and then send the final products back down to Earth. And that makes sense to me. Like, we are living here on planet Earth. It's the only place in the universe that we know of that is as well suited to us as Earth is, and yet we are polluting it. We're filling its skies with carbon dioxide. We are deforesting it. We are wiping out various species at a rapid rate. And there's a limit. There's going to be a limit on how much of this we can take until we're going to suffer as humanity is going to suffer on what we've done to the planet. It's just, people always say like, oh, we're killing the Earth. We're not killing the Earth. The Earth's going to be fine. The Earth doesn't need us, but we're killing ourselves. And so it makes sense to get that heavy industry off Earth. For Musk saying that he wants to have Mars be a secondary home for humanity, sure. Like if an asteroid hits Earth and causes enormous devastation, it's really good to have that second place. But the chances of an asteroid hitting the Earth are incredibly low. Like it hasn't happened in the bad way for tens of millions of years. To the point that, and even like a really devastating asteroid impact wouldn't set back humanity to extinction. It would just set us back. Nuclear war, biological releases, like all of these things, they're bad, but they're not existential for humanity. I think the reason to go to Mars is because it's an adventure. It feels like it's kind of like the next frontier. And I think if you just dig down to it and you ask them again and again and again, but why, it's because it's there, because it's what's next. That feels to me like that's the reason. For most people is we have this instinctual drive to set off into the unknown, to set off into the wilderness, to find a new place that we can call our own, that nobody's ever seen before, nobody has explored. And Mars, the moon, space, other star systems, it's the next logical step. And it doesn't have to make rational sense that you're literally leaving the Garden of Eden to go anywhere else that's worse, but it makes emotional sense. It just feels like that's what's next. And I think for most people, that's what's driving their excitement about us living places other than Earth. But reality has a funny way of crushing your dreams. And the reality of living in space is that it's going to be really, really hard and brutal. And a lot of people are going to die. And at a certain point, people are going to wonder, is it worth it? And so that's my feeling about what's truly driving a lot of this excitement for space exploration. Okay, well, those were all the questions this week. Thank you, everyone, for writing them down across the YouTube channel. Thanks, everyone, for showing up for the live show and asking them directly. Remember, we've got little codes that are showing up with every question. And so vote, go into the comments, write down the code for the question that you thought was best, the answer that you thought was the best, and we'll give a shout out to the person who asked it. All right, thank you, everyone, and we'll see you next week. If you want a single comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights, and links so that you can find out more. Go to university.com/newsletter to sign up. It's totally free. And did you know that all my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to university.com/audio or search for University on iTunes, Spotify, or wherever you get your podcasts. And I'll put a link in the show notes. Thanks to all the moderators, and a special thanks as always to Chad Weber and Nancy Graziano.